Hi there. In this video, I'm going to show you or attempt to show you how to take some survey data and convert text in that survey data to numeric values in RStudio, and then to create some basic visualizations based on those numeric values. There is a blog post that accompanies this video, and the link is here. I'll also put that in the underneath the video on YouTube. And you are going to need, if you want to play along with this, the data that I'm going to be using and the scripts which are in the Harkive GitHub repository. Okay, you're also going to need RStudio installed on your machine. So if you haven't done that, you need to go away and make sure that's the case before you can continue. Okay. So here is what we're going to be looking at, which is data collected from the Harkive 2016 Music Listening Survey, which is a way of gathering some additional information alongside the story gathering element of the Harkive project to give a bit of additional context around people's stories. Okay, the bit that we're going to be focusing on in this example is from section 3, where people were asked to say how often or not they used various different formats to listen to music, which was their least favourite and their favourite, and then also about their engagement with those formats based on certain factors including convenience, cost, collectability, exclusivity, and so on. Okay, so they're the bits of the data that we're going to visualize. This is what the GitHub page looks like, so you should go ahead and download all of the data from there. You've got the 2 R scripts that we're going to be using, plus the data. There's also a document in there that will tell you what each of the questions are within the sample set. The sample set has been anonymized, so there's no personal information from respondents, and it's a sample of 100 responses from the survey. Okay. So let's get going. The first thing you need to do in RStudio is to set the working directory to the directory where you have downloaded the data. So I've downloaded the data here to this folder on my desktop. And just to show you how to do that, if you go to Session, Set Working Directory, choose Directory, and browse for the one that you want. We're in the right one, so we'll have that one, and there we go. It's telling us that the survey data is the working directory. Now you can either open up the first R script doing that, or you can just click on it and it'll open. So we want the survey encoding script first. Just a quick note about the RStudio environment. If you're new to R, in the top left hand corner here you'll see the script that you're working on. Underneath is the console where any commands that you put in the script will run. Down in the bottom right you'll see you can either access help files, view which packages you've got installed, or when you create plots and visualizations, as we will shortly, they will appear in this area. And then in the top right you've got your environment, so any data that you load in, any functions that you create, and so on and so forth will appear in the top right here. Okay, so this first script that we've got is the difference between what you can see in a script here. There are 2 things you'll see. Anything beginning with a hash is a comment, so that just is a good way of kind of you keeping notes or in a script, so you know what each particular line of code does. And then anything that doesn't have a hash before the start will be a line of code. So as a basic example, we'll read in the data from the survey, which is this here, using the read CSV function, and we'll assign it to a variable called H16 for Harkive 16. So you can see now that that's come into our environment, and we can see that we've got responses to various questions in text format. We've got some data about gender, age, and whether or not people responded, whether or not people told stories to the Harkive project or not. Okay, so what we're going to do in this first script is take this information here, which is daily, very often, and so on and so forth, and convert that to numeric values. I should say from the outset that I'm far from an R expert. I'm still learning myself, so if you're a more experienced R user, you might find this a bit cumbersome or inefficient, but it kind of, for me, it works, and hopefully if you're also new to R or a novice in the way that I am, it may even be useful to you if you've got some survey data. Okay, so we've read the data in. What we now need to do is convert those text functions to numeric values, and we're going to use a package called dplyr for that. If you've never used R before you can load a package in, you will need to install it. So you'll run the command install packages dplyr, and then once it's installed, you can load it into the library. I've already installed it, so I can just load dplyr in. Now I've created a function here which matches strings of text, and when it matches a string of text, it will convert it to a numeric value. So we can see here that responses to questions that were daily, very often, and so on and so forth, I've given values of 6, 5, 4, 3, 2, 1, 0. Likewise, if it was a question that asked whether people strongly agree or disagree, there's another function here which is exactly the same, but it's got a different name, and again, it's converting text into numeric values. One of the mistakes I made when I was creating the survey is that I made a few typos. So you'll notice here that on some questions I put never and then space. And here, for example, I use neither agree nor disagree, but also neither agree nor disagree with a capital N. So I found this out during the process of encoding it. So you need to kind of make sure you've got all of your kind of possibilities covered. And what I'm also doing is any responses that were missed, so where people have kind of haven't filled in a particular question, I'm assigning those with a neutral value on the strongly agree and disagree scales. You don't have to do that. You can change these numbers, and in the blog post I talk a little bit about that. So again, here I'm converting text responses to groups. So I want to be able to group people based on what their favourite and least favourite formats are. And again, with importance, it ranges from very important to not important at all. Okay, so there's 4 functions we're going to create there, which we can use to change values within the data set. Okay. So having run those, if we look at column 6 in the data set, which is this one here, we look at the head of it, we can see that the first 6 responses in that column are daily, daily, neither rarely nor often, daily, neither rarely nor often. Okay, so what we want to do is apply the function that converts those words into text to those columns which have responses that are never, daily, and so on. So we're going to do that now, and what that has done is it's created new variables that correspond to the old variables. So the old variable was Q6, we've created N6, Q7, N7, and so on and so forth. So if we have a quick look at N6, or the head of N6, we can see that now that's converted to numeric values, and based on the function that we created, daily is 6, daily is 6, neither rarely nor often is in the middle is 3, daily is 6, neither, and so on and so forth, you can see. So we can kind of be fairly confident that that's worked. We now want to bind these new variables to our existing data frame. So we can see at the moment we've got 88 variables, so 88 columns in the data frame of 100 observations. When we run this and bind those new variables to the data frame, that should increase by 7, all being well, which it did. And now what we can also do because those 7 responses are kind of related in the sense that they relate to these questions here about formats. Okay, um, we can create some kind of sums on those, so we can add up the amount of engagement people have with different formats and create a new variable with that. And we can also create some means and standard deviations based on those numbers. Again, it's in the blog post talking about the kind of pitfalls of using means and standard deviations with survey data. So again, you need to be kind of careful, but the purpose of this here really is just to kind of show you how you can convert and create new variables from text data. Okay, standard deviation. Here, what we're looking at is if somebody answers daily to all of these, then there's not much deviation in their responses. You know, they're fairly consistent. However, if they're all over the place in various places, then you know they have different relationships with different formats. And obviously, the higher the number of the sum, the more they engage with different formats. So just to show you what I mean by the standard deviations, if somebody had answered 0 to all, they would have a standard deviation of 0 because there's no difference between their responses. Likewise, if they had answered 6 to everything, they would have no deviation. But if they're a bit more over the place, all over the place with their responses, such as that example, then obviously the higher the standard deviation, if that makes sense. Okay, we've now got questions 14 and 15, which we also need to convert. So questions 14 and 15 relate to these two questions here. What is your favourite and your least favourite? So we're going to use the different function, which we created above, which converts the names of formats into letters, which we've now done. And we're going to then do 16 to 22, which are these questions here about convenience, cost. So this is not important, unimportant, somewhat important. And we're using the function that we created above called importance. And then we're going to bind those to the data frame. Again, and do the sums, again, like we did on the other group about the amount that people engage with different formats. Now, I won't bother going through the rest of it because this is essentially doing the same process with all of the other parts of the survey from questions 23 through to 90. But you can take your time and have a look at this in a bit more detail if you want. You'll see that it runs through relatively quickly and converts that entire database. And then we want to get rid of those. Again, you don't have to, but I'm going to get rid of the original text-based columns that we've got in here because we've converted them now to numerics, which are all over there. So let's go ahead and remove those. So if we have a look at H16 now, we should see that we've converted all of those text-based responses into numeric values, and for each section of responses we've got sums, means, and so on and so forth. Okay, so what we've now got is we've taken the original text-based spreadsheet, which is still here in your original folder, okay, and we've converted it to numeric values. So what we want to do before we move on to the next bit is create a new CSV file of that, so we don't have to go through this work again every time. And that really is just the opposite of what we did previously when we wrote in some data. We're just going to write out some data using the right CSV format. We're writing a CSV file. It's the H16 data that we want to use to do that, and we're going to call it survey sampled encoded. Okay, so if we run that, because we've set the working directory to this directory, what we should now find is that is in our folder, which it is, and if we have a quick look at it, we'll see that there's our data. Okay, so now we can move on to doing some visualizations. So let's go ahead and make these visualizations. What I'm going to do, you don't have to do this, but I'm going to clear out what we've got in the environment and kind of start with the second script, because we've already got the encoded data. Yeah, we can just kind of treat this as a separate step. So let's open up the visualization script, which again you'll find in the GitHub. I've provided a bit of information here about the questions that we're going to visualize. Again, we'll begin by reading in the data. Now, what we're going to read in this time is the encoded sample. Okay, but again, we'll assign it to the H16 variable. Obviously, if you hadn't written this out as a CSV file, it would still be in there as H16 because of the work that you've previously done on it. But let's just double check to make sure that we've got the right thing, which we have. We've got all of our numeric values and our groups here around formats, which we'll see in a second. There are three packages you're going to need to run through this. Again, if you don't have them installed, it's a case of typing in the names of the packages below for each of the three, but I've already got them, so I'll just go ahead and load those in. So what we can do is just some basic plots to begin with, and what I'm going to try and do is build up from a basic plot to show you how you can add variables to a plot in ggplot to make them a bit more useful to you. What we're doing here, just to break it down, is this I believe is referred to as piping. So you're kind of saying apply all of the things that I put beneath this piping function to the H16 object. Okay, so here all you need to remember when you're building these up is that each one goes on a new line, and you need a plus sign after each one, apart from the last one. So in this one, what we're saying is take the H16 data, use ggplot to put the sum from the questions 6 to 12 responses and the standard deviation to the 6 to 12 responses on the x and y axis, and just give us some points. Okay, so if we run that, you'll see that we get a plot here in the bottom right hand corner. So just to recap on what we're looking at, we're asking people here about the amount of time, or how often rather, they engage with, they listen to music over these 7 different formats, ranging from never to daily. So the sum is adding up all of those, so the higher the number, the further they will appear to the right, and the more they engage with different formats, and the higher the deviation, the more difference there is in their responses between different formats. So here's a basic plot. It doesn't really tell us a great deal because we've just got some black dots, although we can see that some people engage with a hell of a lot of format, with almost all formats, because the highest possible score you could get here with would be 42, because there are 7 responses and the highest response is 6. Okay, so some people over here are kind of in the mid 30s, whereas other people here are down in the kind of the 10 and below. So they are obviously engaging with one format or a couple of formats, and then others not. So this is why they've got a higher kind of deviation, I guess. Okay. So what we can start doing is adding in some more information by adding variables to the plot. So this next one is going to shape these dots on the screen according to gender. So again, it's identical to the one above, except that we're saying use Q1 which is gender, as you can see here, to denote the shape. So if we run that, we should see that what we've now got are triangles for male respondents, circles for female respondents. Those who indicated other are squares, which you can see there, and rather not say is a cross. What we can do is we can add some colour to that plot, and we can also filter out some responses. So what I'm going to do in this next step is I'm going to filter out, we've only got a handful of responses that say rather not say or other, so we can filter those out. Again, you could filter out people based on gender, you could filter out all the females, filter out all the males, you could filter out according to age, and the way that we do that is by adding to this pipe of instructions to H16, as we're saying, filter out question 1 where it does not equal rather not say or does not equal other. So anything that doesn't equal rather not say or doesn't equal other will be allowed through. Again, we're saying we're going to plot it. We'll put in the same things on the X and Y axis. We're still using gender for the shape, but we're going to colour the dots on the screen according to Q2, which is age, okay, as you can see there. Okay, so if we run that, we should see that it's starting to take a bit more shape now. Okay, the other thing to kind of be aware of before you go any further is obviously this is a random sample, so just looking at that there, you might kind of infer that people in their 30s do a particular thing, people in their 40s and 50s do a particular thing. But if we very, very quickly plot out the age variable, we can see that because it's a random sample, it's probably not it's not completely even across the age ranges. There's a lot more people within those age groups than any other ones, so it's kind of understandable why you would see more dots on the screen that are green and blue denoting those age ranges. Okay, so just be aware of that. We can also you'll also notice in that previous one that it's taken the names of the columns in the data set to label up the visualization, so we can add those in by giving the plot a title. We can name the x-axis, the y-axis. So I've named the y-axis regularity of multi-format engagement. So and the other one is volatility. It may not be the correct term, but it'll do for now. And we are changing the legends on the right hand side to match the fact that they relate to age and gender. And the other thing I'm going to do with this one is you'll notice in the previous things that we had G on point, so that's points on a graph. We want to now use jitter, and the reason for using jitter is that introduces a little bit of random noise into the visualization. So if you've got one or more items that score exactly the same, and you can kind of just see that there, that there's a blue circle and a green triangle sat on top of each other. If we run a jitter rather than a point command, it kind of separates them out a little bit without kind of completely distorting what you see. So if we run that now, we can see that it's moved things slightly apart. So you still know that this is in the neighborhood of 25, but you can see that there's actually two data points there. Okay, and now it's telling us a bit more information because we've got age, we've got gender, we know what the X and Y axes are. Okay, you can try and change these around a little bit. The geom variable of ggplot, there are various other ones that you can use, all of which are listed here. Some will suit the data that you're working with, others won't. So if we change that to line, for example, instead of getting points, we'll get a line. But that doesn't really tell us a great deal from that data. It just, even though it's quite pretty. So we'll stick with the jitter because that was a bit more useful to us. Okay. What you can also do with these visualizations is you can write them out in the same way that you can write data out. You can write visualizations out. So if you want to create a PDF of this particular visualization, you just wrap the original command, which is there, in a PDF command. So you're saying here, use the PDF function to create a file called h6_12 PDF. The size is 7 by 7. And then just remember to close it off with the dev.off command at the bottom. So if we run that, what we should find is that in our working directory, we'll have a PDF of a visualization. And likewise, you can also create JPEG files. Okay, the only difference between a JPEG file and a PDF file, as I understand it, is that you can't specify sizes in the JPEG command. Okay, so you just kind of get what you're given with that. Obviously, this is useful if you want to put visualizations into blog posts or reports. However, in a later video, I'll deal with using R Markdown as perhaps a more efficient way of doing that. But there's the JPEG that we created. No, it isn't. There it is. There we go. There's the JPEG that we created. Okay. So there's some basic visualizations and writing to your database. Now we can plot favorite formats, which is data that we've also got in. So again, this is just building on the previous plots from before, but we're still filtering out rather not say and other on the gender, but on the formats one, we're going to filter out anyone that's missed that question, so anyone that's put a blank response. We are again using the format engagements, but this time I'm going to colour it according to N14, which was the question about which was a person's favourite format, and we've changed the levels here to represent, the legends to change to represent the changes in the data. So again, we'll run that, and again we can see here that various things are represented. This is favourite format, and there's kind of the danger that you could kind of see an over-representation of physical formats as in the data. But again, if you plot that out, we probably expect to see that physical formats might be over-represented in the data as a whole, which B is kind of features quite heavily. So yeah, just be aware of that if you're looking at visualizations, to consider the data set as a whole. Okay, again, we can plot least favorite format, and you can kind of look at these in a bit more detail if you want, and change some of these parameters around. But again, least favorite format, this time we've done it by age. Again, the regularity of the format engagement, colored by favorite format. Okay, so you can see there's a lot of ways you can take this numerical data and kind of play around with it in visualizations to see if you can see any interesting patterns in the data. We could also kind of, as you kind of look through, questions might occur to you, and it's then easy to kind of create other variables that might help you answer them. So we could ask a question here of, for example, does the kind of volatility of their format engagement affect their engagement with formats? And we can create a new variable that divides the standard deviation by the sum, and then we can plot that out. Okay, and the other thing that I've put in here as well is a line that kind of indicates the mean along all of the data. So the interesting thing, I guess, looking at this without thinking about it too much, is that you've obviously got the main grouping around there, but then you've got these outliers here, and it might be interesting to look in a bit more detail at why these particular people are outlying. Certainly from the point of view of my research, with having the stories that I can look at, I might want to pick out these people here and see what they're saying based on this information. And now, finally we can start bringing in motivations for listening, which are questions 16 to 22. So here we're going to look at how important the total number of reasons are for choosing a particular format against the total number or level of engagement with different formats. Okay, and again, as before, we're changing the names of the legends on the various axes and title and legends and so on. And you can also break it down and look at something such as convenience versus cost. So, the importance of convenience versus the importance of cost for people. And in this case, we're colouring it by age, and we're shaping it by gender. I'm just getting emails here through. Sorry about that. If you run that, our support now. So here we can see that cost and convenience, it's kind of a bit of cake and eat it, I suppose, but people think convenience is important, but also the cost of an item is important. So again, you can see a kind of trend going there. But and again, it might be interesting to pick out the people who are down here and the people that are up here when looking at the story data. And one more, we'll look at convenience versus exclusivity, which is in the data set also. And again, we get a different sort of shape. So hopefully you can see from doing that within this data set I think there are 86 different question responses. So from there, if you're interested in music listening and people's responses to the survey, then hopefully by using this these templates for visualizations, you could maybe have a play around with the data and come up with some things for yourself, or you could use either of these two R scripts on your own survey data by adapting it. Anyway, I hope that was useful. Thanks a lot.